Good day, everyone. My name is Oyewuse Edwan. So I am very happy today. We are going to start the journey that I had talked about in my previous video, your journey to understanding mathematics. And today, numerous classes that we will take in going through this journey. So I hope you all enjoy and stay tuned to the video and make sure that you really learn whatever it is that you don't understand. Do not shy away from liking the video and comment whatever it is that you don't understand, so that we can both go through about it together. So you can also follow me or subscribe to my YouTube channel at Adidolapo, so that we can all benefit from this together. And don't forget to share our video for other people's benefit. So thank you. Let's start the journey. Yes, this is our first class in what I deemed your journey to understanding mathematics. So our first topic is number-based system. Before we go into the workings and all that, let me explain the number-based system to you. Now, in number-based system, we have a lot of number bases. We have the decimal, which is in base 10. We have the binary, which is in base 2. And we have the octal, which is in base 8. And we have the hexadecimal, which is in base 16. So, in order for us to understand how this number-based system work, let's look at this base 10, because it is what all of us have been familiar with since the time we have started going to school. So we know that number starts from 0 to 1 to 2, 3, 4, 5, 6, 7, 8, 9. So aside this, there is no other number, because all other numbers that we know are the mix of these different numbers. And that is why, because we are all these numbers that we have been familiar with, they are all in base 10. That's why if you count the digit 0, 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see for base 10, we have just 10 digits. For base 10, for a number in base 10, there are only 10 digits from 0 to 9. So if you count them, you see that they are 10. So for each type of base, actually we can also work in all other bases like base 3, base 4, base 5, but this one that I listed out are the most important base system. So that is why we have to talk with these 4. Now I hope you are following me. For a number in base 2, that is the binary, you cannot have more than 2 digits, which means in decimal number base system you can have 10 digits, which is 0 to 9. So all other numbers are the mixtures of this. So that's why you have 9 and 0, 90, 1 and 2, 12, 1 and 3, 13, and all other numbers that we know. But in binary also, as we know that is in base 2, you can't have more than 2 digits, which is 0 and 1. So for every number in binary system, it will be the mixtures of these 2 digits. The same thing with octal. You can't have more than 8 digits, which is 0, 1, 2, 3, 4, 5, 6, 7. That's it. So in each number based system, you cannot have the number representing the name of the base, which is in base 2. You cannot have 2 there. If I write a number like this 102, and I want to ask for me to say, okay, the kind of base that it is supposed to be, so it can, because of these 2 present here, it can never be in base 2. It can never be. So the least base that it can be is base 3 going upward. It can be base 3, it can be base 4, base 5, or any other. But since these 2 is present, it cannot be in base 2. So we have to understand that. So for hexadecimal, which is base 16, we have only 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So which means these are all the numbers present in what? In base 16. So A represents 10. Since we cannot write just 10, because this is a mix of two other numbers, 1 and 0. So we use in base 16, we use letter A to represent it, B to represent 11, C to represent 12, this to represent 13, this 14, and this 15. So one thing I also like to quickly share is when you are adding base. So let's take this for an example. As an example, so if we are adding in base 10, let's say I have, or let me use subtraction. I want to subtract 29 from 21. The normal way, you know, when we borrow 1 from this, we say the 1 will become 10. That's because we are working in base 10, which is the decimal, the common number base system. So that's why the number that we borrow will turn to 10, and then we add it to this one, making it 11, and then we subtract 9 to give us 2, and this one will remain 1. Now if you are working in base 2, 1, 1, you want to subtract 1, 0, you want to add, let's say we want to add now. So, or let me say, yeah, you want to subtract. Let me use subtraction to explain it easier. In base 2. So you know I cannot subtract 1 from 0. So when I borrow 1 from this place to this place, it returns to 2 because I'm working in base 2. So the 0 now, I now add it with the 0, which is what? 2. I now subtract 1, which is 1. Which means in base 2, 1, 0 minus 1 will give us what? 1. In base 2. So the same thing with all other bases. So this will be the end of the explanation for the number base system before we go into the workings itself. Thank you.